Today we're going to learn three different types of methods when balancing redox reactions. The first of the three types of methods is called the half reactions method, and you use this method when you have H+, OH-, and waters present in your original reaction. Step 1 is to assign oxidation numbers to everything. Step 2 and 3 are to write the oxidation and reduction half reactions. Step 4, you are to balance for charge. Step 5, you are to rewrite the original equation with the factor from balancing for charge. Step 6, you are to balance for mass and charge at the end. Example. So here's my original equation. Okay, my first step again is to assign oxidation numbers. When I go through the original equation, I go ahead and, just like before, the original skill that you learned in this unit, you are to apply those oxidation numbers to each one of those species in the reaction. Step 2 and 3, you are to write the oxidation and reduction half reactions by taking a look at what's happening to each of these numbers, these oxidation numbers. Are they increasing or decreasing? If they're increasing, that means it's being oxidized. If it's reducing, then that means it's being reduced. So when I take a look here, I know Cr goes from 0 to +3, so that's my oxidation half reaction, and I need 3 electrons to balance out the charge. And P goes from +1 to 0, so I need 1 electron in order for it to be reduced. Step 4 is to balance for charge. So, in other words, I need equal numbers of electrons being transferred. So I have 3 in the oxidation half reaction, but I only have 1 in the other, in the reduction half reaction. So I'm going to take the coefficient 3 and apply it to that entire equation so that I end up with 3 electrons in the reduction half reaction. So here it is, simplified. Now what I'm going to do is I'm going to rewrite from the original equation these species that have these letters in them. So in other words, anything with P in it, I'm going to apply the 3. Okay? So in other words, this species I'm going to add a 3, and this species I'm going to add a 3. Okay? And here it is. So the last step is to balance for mass and charge. In other words, everything, all the atoms in the equation need to balance out. Okay? First step that I do is I count up the number of oxygens, and the number of oxygens in this case are going to equal the number of H2Os. Okay? So on this side I have 6 O's, so therefore I'm going to have 6 waters. Okay, and then the last step, what I'm going to do is I'm going to balance out the number of H's. So on this side I have 9 H's, but I only have, and I have 12 on this side. So in other words, I need 3 more. So I'm just going to go ahead and put a 3 right there. So our final balanced equation looks like this. Okay, you keep the oxygens for second to last, and then you balance out those with waters, equal numbers of waters, and then finally you balance out the waters, the H's in the waters, plus all the other H's in the balanced equation by applying those